2 o'clock this afternoon, the National Hurricane Center in Miami issued its routine tropical weather outlook. 7 words carried almost the entire message. Tropical cyclone formation is not expected during the next 7 days. No name, no advisory number, no cone of uncertainty on the map. If you glanced at that bulletin without context, you'd assume there's nothing happening in the tropics at all right now. You'd be wrong. As of today, Monday, July the 27th, the National Hurricane Center is actively tracking 4 separate tropical waves across the Atlantic and Caribbean basin, and one of them has just crossed into the Caribbean Sea itself, moving westward on a track that will carry it directly through some of the most consequential real estate in the entire Atlantic hurricane basin over the coming days. I need you to understand why nothing is expected to form and this is genuinely worth watching are not contradictory statements. Most tropical waves never become anything. Most of them cross the Caribbean, run into dry air or wind shear, or a disruptive mountain range, and quietly fall apart without ever making a headline. But every single hurricane that has ever hit the Caribbean or the United States started out as exactly this, an unremarkable-looking wave of low pressure that nobody outside a small community of meteorologists was paying attention to yet. So today, we're going to walk through exactly what this wave is, where it came from, what the other 3 waves currently being tracked are doing, what would actually need to happen for any of them to develop, and what you should genuinely be watching for over the coming week if you live anywhere in this wave's path. Let's get into it. Let's start with the wave that's actually the subject of today's video, because it has a specific traceable origin story. Just this past Friday, July 24th, forecasters were tracking 2 new tropical waves that emerged in the wake of Tropical Storm Bertha's dissipation earlier this season. One of those 2 waves was already positioned along 62 degrees west longitude, actively moving into the Caribbean Sea with scattered moderate convection, or meaning clusters of showers and thunderstorms, developing just ahead of it, roughly between 12 and 15 degrees north latitude and 62 to 65 degrees west longitude. That positioning put it just east of the Lesser Antilles, the small island chain that includes places like Martinique, Guadeloupe, Dominica, and St. Lucia, right at the eastern gateway into the Caribbean basin. By today, Monday, that same general disturbance has been tracked further west, now identified in the National Hurricane Center's tropical weather discussion as a wave in the central Caribbean, with its axis running along 71 degrees west longitude, extending south from 18 degrees north down into Venezuela. Over roughly 3 days, this system is pushed from the eastern edge of the Caribbean to the central Caribbean, putting it somewhere in the vicinity of the waters south of Puerto Rico and Hispaniola, and it's continuing to track westward. That's the core story here, a tropical wave born from the same broader pattern of disturbed weather that spun up tropical. Storm Bertha has now entered the Caribbean Sea and is actively crossing it, and it's doing so during exactly the stretch of the calendar when this kind of system needs to be watched most closely. Before we go further, let's actually explain the mechanics here, because tropical wave gets thrown around constantly during hurricane season without much explanation of what it physically is. Most of the tropical waves that eventually threaten the Caribbean and the United States start their lives as what meteorologists call African easterly waves. They form over the African continent, often near the transition zone between the Sahara Desert and the more humid regions to the south, and they're essentially ripples or kinks in the broader easterly wind flow that dominates the tropics. As one of these ripples moves off the West African coast and out over the Atlantic Ocean, it can organize a cluster of showers and thunderstorms around it, riding westward on the prevailing trade winds at roughly 10 to 20 knots. Not every wave carries the same amount of energy or organization. Some, like the wave the National Hurricane Center is currently tracking near the Cabo Verde Islands off Africa's coast. I show only isolated clusters of convection, a weak, loosely organized disturbance. Others, like a separate wave currently positioned along 54 degrees west in the central Atlantic, are showing more substantial scattered moderate convection across a wider span of latitude. The strength and organization of the convection around a wave when it's still out over the open Atlantic is one of the first things forecasters look at to gauge whether it has real potential. Though plenty of weak-looking waves surprise everyone later, and plenty of impressive-looking ones fall apart within days. These waves also interact with 2 other features you'll hear meteorologists mention constantly this time of year: the monsoon trough and the intertropical convergence zone, or ITCZ. The monsoon trough is a broader area of low pressure and converging winds that stretches across the tropical Atlantic during peak summer months, entering the ocean near Senegal on the West African coast and extending thousands of miles westward. The ITCZ is the band, close to the equator, where the trade winds from the northern and southern hemispheres physically collide, forcing air upward and fueling persistent showers and thunderstorms along its length. Individual tropical waves often ride along or near these larger features, drawing additional moisture and instability from them as they cross the Atlantic. which is part of why forecasters track the position of the monsoon trough and the ITCZ as carefully as they track each individual wave. It's also worth knowing that forecasters don't track these waves as one continuous thing from the moment they leave Africa. A wave's axis, essentially the line of lowest pressure and most concentrated showers running through the disturbance, gets reanalyzed and repositioned in every single tropical weather discussion, sometimes multiple times a day, based on the latest satellite imagery and surface observations. That's why you'll see a wave described at one longitude on Friday and a noticeably different longitude just 3 days later. It's not a new system each time. It's the same disturbance being continuously remeasured as it physically moves. Forecasters also track roughly how many named African easterly waves have emerged off the continent so far in a given season, since the total count and spacing of these waves gives climatologists a rough sense of how active the broader wave train has been compared to a typical year, even before accounting for how many of them actually develop. I want to walk through the entire board the National Hurricane Center is watching right now, because understanding the full pattern tells you a lot about where we are in the season. First, there's a tropical wave in the eastern Atlantic with its axis running right across the Cabo Verde Islands near 25 degrees west, extending from 9 to 18 degrees north, moving west at 10 to 15 knots. This is a classic, freshly emerged Cabo Verde type wave, showing only isolated clusters of moderate convection at this stage, essentially a system that's barely gotten started on what could be a multi-week journey across the Atlantic if it survives that long. Second, there's a wave in the central Atlantic along 54 degrees west, extending from 9 to 21 degrees north, moving west at a brisker 15 to 20 knots. This one is showing more organized convection, with scattered moderate thunderstorm activity along both its southern end, between 5 and 9 degrees north, and its northern end, between 16 and 21 degrees north. A wave showing convection at both ends of its structure like this is generally considered a bit more robust than one with only an isolated single cluster. Third is our main subject, the wave in the central Caribbean along 71 degrees west, tracking through the waters near Puerto Rico, Hispaniola, and northern Venezuela. And fourth, there's a separate tropical wave already in the southwestern Caribbean, with its axis near 78 degrees west, running from 18 degrees north southward all the way to eastern Panama, moving west at 15 knots, with widely scattered moderate convection south of 14.5 degrees north between 78 and 82.5 degrees west. This wave is already positioned close to the Western Caribbean and Central America, putting it in a region where it could interact with land relatively soon, or potentially reach the far southwestern Caribbean and Gulf waters if it survives its current track. 4 active waves in one basin at varying stages of their westward journey is a genuinely normal picture for late July. This is what meteorologists sometimes call a wave train, a steady procession of these disturbances marching off the African coast roughly every 3 to 5 days during the height of the season, each one an independent roll of the dice on whether conditions align for development. So let's get to the actual question. Everyone watching this story once answered, what would it take for the Central Caribbean wave, our main subject, to become an actual named storm? A handful of specific ingredients need to line up. Ocean water needs to be warm enough, generally accepted as at least around 26.5 degrees Celsius, roughly 80 degrees Fahrenheit, extending to a reasonable depth below the surface, not just at the surface itself. Wind shear, meaning the change in wind speed and direction with height, needs to stay low because strong shear physically tears a developing storm structure apart before it can organize a closed circulation. The surrounding air needs enough moisture, since dry air, including the kind of Saharan dust that frequently streams off the African coast earlier in the summer, can choke off the thunderstorm activity a wave needs to sustain itself. And the wave needs enough distance from the equator for the Coriolis effect, the force created by the Earth's rotation, to actually impart the spin a tropical cyclone needs. Waves that stay too close to the equator often can't develop real rotation, no matter how much thunderstorm activity surrounds them. As of today's National Hurricane Center outlook, none of the 4 waves currently being tracked are given any real chance of formation over the coming 7 days. That's a meaningful official assessment, not just an absence of information. It reflects the current model guidance and atmospheric analysis genuinely not supporting development for any of these systems in the immediate future. But not expected in the next 7 days is a rolling assessment, not a permanent verdict. Conditions this far out in the Caribbean and Gulf can shift meaningfully as a wave continues its track, particularly once it clears any interaction with the mountainous terrain of Hispaniola, which is notorious for disrupting a wave's low-level circulation as it crosses. Hispaniola specifically deserves its own mention here, because it plays an outsized role in the fate of exactly this kind of Central Caribbean wave. The island's central mountain ranges rise high enough to physically disrupt a weak or moderately organized system's low-level wind field, essentially scrambling the surface circulation, a developing storm needs to hold together. Meteorologists have a long, well-documented track record of watching promising-looking waves fall apart crossing this exact stretch of terrain, only to occasionally watch a system re-emerge and reorganize once it clears the island's western coast and reaches the open water of the Windward Passage or the northwestern Caribbean. That's precisely why the coming few days of this wave's track matter disproportionately compared to earlier or later stretches of its overall journey. The Hispaniola crossing is close to a make-or-break moment for a system at this stage of development, or lack of it. Context matters here, so let's zoom out to the full 2026 Atlantic hurricane season picture. Bertha, the storm whose dissipation spawned this wave and its counterpart, was this season's second-named system, giving you a sense that we're still relatively early in what meteorologists consider the more active stretch of the season, which typically runs from mid-August through October. NOAA's Climate Prediction Center has put out an overall outlook calling for a below-normal Atlantic season this year. That's genuinely useful context, and it should temper any instinct toward panic over any single wave crossing the basin right now. But I want to be very direct about something here, because seasonal outlooks get misused constantly in exactly the wrong direction. A below-normal season forecast describes the expected total number of storms across the entire 6-month season. It says essentially nothing about whether any individual system, including the one we're discussing today, ends up affecting a specific island or coastline. It only takes one well-timed storm hitting a populated area to make for a devastating season locally, regardless of what the seasonal totals eventually add up to. Treat a below-normal outlook as a reason to feel a bit more at ease about the overall volume of storms this year, not as a reason to let your guard down on any individual system actually crossing your specific part of the map. Here's something worth understanding clearly. A tropical wave doesn't need to become a named storm to cause real, tangible impacts on the ground. As this central Caribbean wave continues tracking westward, the moisture and instability associated with it are capable of producing locally heavy rainfall, gusty winds, and rough surf across whatever islands and coastal areas it passes near, even without ever organizing into an actual tropical cyclone. The Lesser Antilles, Puerto Rico, the Dominican Republic, Haiti, and Jamaica are all realistically positioned in the wave's general path over the coming days, depending on exactly how far south or north it tracks. Increased shower and thunderstorm activity, locally gusty winds, and elevated seas are a completely normal and expected impact from a wave like this, independent of whether the National Hurricane Center ever upgrades it with a name. This is also exactly the kind of scenario where regional weather services across the Caribbean, not just the National Hurricane Center itself, matter enormously. National meteorological offices across the islands issue their own localized rainfall and wind advisories tied to a passing wave's moisture, often well before or entirely separate from any tropical cyclone-specific product from Miami. So what does active monitoring of a system like this actually look like day to day? Forecasters at the National Hurricane Center are updating the tropical weather discussion multiple times per day, tracking the wave's exact axis position, its forward speed, and the extent and organization of convection around it, using a combination of satellite imagery, surface observations, and specialized products that estimate rainfall rates and cloud-top temperatures from space. As the wave continues westward, meteorologists will be watching specifically for any sign of a closed, low-level circulation beginning to form, a genuine spin developing near the surface, rather than just a broad, disorganized area of showers and storms riding along the wave's axis. They'll also be watching the wave's interaction with Hispaniola's mountainous terrain closely, since that interaction has disrupted or entirely destroyed the low-level circulation of numerous historical systems crossing the Caribbean at this exact longitude. A wave that survives that interaction intact and reorganizes once it reaches the open water of the Western Caribbean or the Gulf sometimes has a genuinely better shot at development than it did before making landfall over the island's mountains. If model guidance and satellite trends did start suggesting a better chance of organization, the National Hurricane Center would formally raise the system's development odds in its tropical weather outlook, first typically in a longer 5 to 7 day window and separately in a shorter 48-hour window with specific percentage likelihoods attached to each. If conditions warranted it, a Hurricane Hunter aircraft reconnaissance mission could also be dispatched to fly directly into the system, gathering wind speed and pressure data that satellite imagery alone can't fully capture. None of that has happened yet for this wave. And as of today's outlook, none of it is expected to happen in the coming week. But that's precisely the escalation pathway to watch for. If this specific system's outlook changes, there's one more geographic wrinkle worth flagging for this specific wave's longer-range future. Even if it doesn't organize while crossing the Caribbean itself, waves at this longitude sometimes survive their transit relatively intact and reach the Bay of Campeche, or the broader Gulf of America waters west of Florida, where warm sea surface temperatures and a fresh atmospheric environment occasionally give a struggling system a genuine second chance at development that it didn't get over the Caribbean. That's speculative for this particular wave right now, and nothing in today's outlook points toward it, but it's a realistic enough pattern historically that it's worth knowing as part of the fuller range of ways a story like this can eventually unfold over the next week or two. If you live anywhere in the Caribbean, from the Lesser Antilles through Puerto Rico, Hispaniola, Jamaica, or in the wider Gulf and Central American region, this wave could eventually reach. Here's what I actually want you to do with this information. First, treat late July as legitimate hurricane season, not the calm lead up to it. We're past the traditional early season lull, and this exact stretch of the calendar, heading into August, is when tropical wave activity across the Atlantic and Caribbean genuinely starts to intensify in both frequency and potential. Second, if you haven't already put together a basic hurricane preparedness kit, this is a good moment to do it while there's no active storm creating supply shortages or panic buying. Water, non-perishable food, a battery-powered radio, flashlights, and copies of important documents in a waterproof container are the basics, and building that kit calmly this week beats scrambling for it under an actual watch or warning later. Third, identify your actual information sources now. Know your National Meteorological Service's specific channels if you're on one of the islands in this wave's potential path, and know how to access the National Hurricane Center's tropical weather outlook directly, rather than relying solely on secondhand social media summaries that can lag behind or distort the official guidance. And fourth, don't let the below normal season framing lull you into complacency. And don't let a single unremarkable looking wave send you into panic either. The honest, useful posture right now is calm attentiveness, checking in on the system's status every day or two as it continues its track, without needing to treat every single wave crossing the basin as an emergency in the making. So here's where this stands as of today, Monday, July 27th. A tropical wave that entered the Caribbean late last week, born from the same pattern that spun up this season's tropical storm Bertha, has now tracked into the central Caribbean near 71 degrees west, moving through waters south of Puerto Rico and Hispaniola. It's one of 4 active tropical waves the National Hurricane Center is currently tracking across the Atlantic Basin, and as of today's outlook, none of them are expected to develop into a tropical cyclone over the coming 7 days. That's genuinely reassuring information, but it's a rolling assessment, not a permanent one. And this specific wave's interaction with Hispaniola's terrain over the coming days is exactly the kind of moment that can change its trajectory, literally and figuratively. I'll be tracking this wave, along with the other 3 currently on the board, over the coming days, watching specifically for any sign of a closed circulation developing or a shift in the National Hurricane Center's formation odds. This is exactly the kind of story that looks like nothing is happening right up until it very suddenly is, and I'd rather you hear about it now, while it's still calm, than after a watch or a warning is already posted. If breakdowns like this help you stay properly informed through hurricane season, subscribe, because I'll have the update the moment anything about this wave, or any of the others, actually changes. I'll see you in the next one.